Data structures are an important part of programming, and if you want to know about queues, then you need to know about deque. Deque is a double-ended queue from collections, and this video includes what is a queue, why use a queue, and how to use a queue. Here's a queue and here's a stack. They are both data structures. Now the queue is the same as in real life and the stack is the same as in real life. We enter into a queue at the end of the queue and we exit at the front. So the same as if you're waiting for the ATM and there's a few people, you join the end of the queue and the first person in the queue will go to the ATM. Now the stack, the same like a stack of books. You put a book on the top. Well, if you want to take any off, you will have to take off from the top as well. So let's have a look at that in action. We have the queue. We can add an element at the end. We take one off from the beginning. We can add an element at the end again. So that's a queue. We look at the stack. We're going to put one on the top. We want to take something off, so we have to take off from the top first. Then the next item at the top, if we want to add, we add at the top. So there's a problem with this because when we use a list in Python, we don't normally take something from the beginning of the list. So if we remove the beginning, then all the other items have to move up, which is not very efficient. So how do you implement a queue? Simple. You use deque, the double-ended queue that's in from collections. Let's have a look at that in the code. Let's start off making our queue. So we can say queue equals deque, and then how are we going to start our deque? So if we print that, you can see that when we print it, we have our deque. Now if we add to that, we can just use append. So let's append 6 and print again. And we have our deque, as you can see. If you want more than one item, you can use extend, the same as you would be able to with a list. So let's put 7, 8 and 9 added on. And we can see our new queue. Now if we want to pop that, we can take an element off the end. So we can see now we've lost the 9. And the most important part is that we can take off the front. So let's pop left and you can see we've taken the 3 off the front. So we can use the double-ended queue, pronounced deque, taking elements off the front, which is the crucial point, so we can implement the queue in Python. What have we got online? Well, we can implement a queue. Here's some code to do that using the class queue. We can implement a stack. This is also from the Runstone Academy website. Now Geeks for Geeks normally does some good explanations of why we might want to use the code and some examples. So here we can see about the time complexity of using the deque is better than the list. And if we look down, we can see an example. We can see the options, the methods we can use: append, append left, pop left. Some example code, and you can scroll down there for more options that we can see. We're not really going to cover looking at rotating and reversing the queue. And here's a website from Educative that has a demonstration. We've got the deque that starts with 4, 5, 6. So we can add, like we can append to the end, which adds at the end of the queue. We can actually append to the beginning, which is not really what we want. we can extend the same like we can a list. Again, we can do at the front, we can insert. Now pop, we can pop at the end, but also we can pop left, which is important for our queue. Other things we can do is remove, we can count, put index, even rotate 3, rotate again, and reverse. So there's a demonstration from a website, things that you can do with the queue. So why use a queue? Well, here's an example where there's a lot of calls and the service that takes all these calls can't cope with them. There could be many at any time. Maybe one customer makes a lot of calls. How do you deal with these calls? The simple way is a queue. You put the calls in a queue, you deal with the first in a queue, any new calls go to the end of the queue, and you can set a time of how many calls you can answer in a given time period. So that's one method of a queue. Now, just to show an example why you might use a stack, here's a maze. Now there's 3 points you can see here, 1, 2, 3, where decisions made left or right. So we can think of this as a choice between either going left or right, left or right, left or right. So how we would implement that, we would look at going maybe, let's say we've got an algorithm that chooses left. If it's not left, it goes right. We can put that in a stack. So first of all, we go left, that's fine. Then we go left again. So we put left in the stack. Now we're in the wrong place. So we can take out that left, put in the right. Now again, we've got left, and now we've correctly exited the maze. So we can use a stack when we implement that algorithm to get out of that maze. So in code, we could use push. So we put in the option of left, and we want to take something out, we can pop that. So push again is enter, enter again is push, and when we want to exit, we can use pop. Let's have a look at another example from computer science. Here we're going to use a search of a tree. Breadth first search, which kind of goes along, and a depth first search that goes down first. So let's have a look. Here we've got a tree of A, B, C up to O, and you can see the breadth first search looks at the first node, then the next level down, those nodes, and then goes to the next level, goes across, if you like. That's why it's called breadth first search. So it goes down each level and looks at all the nodes at each level. So that's called a breadth first search. Now we would implement that using a first in, first out queue. So you add to the end of the queue and you exit from the front of the queue, deque. So breadth first search would look at A, then B and C, then D and E, then F and G. Now depth first search is different. You start off at A, but once you get B and C, you look at B. Now B has D and E, so you go depth first, you go down first, so you would go to D. And then D has children nodes H and I, so you would look at H then. So it goes down first from A, B, D to H, then it would go I, and then go back to E, and then it would complete the first side, the left hand side, all of that before it would go to the right hand side starting with C. So that's a depth first search, and that would be implemented using a stack, last in, first out. So you can see that would go A, then it would go B, then D, then H, then I, then E, then J, then K, then go on the right hand side C, then F, then L, then. So you can see there the difference between entering a stack where the last thing that was put on the stack is the first thing that comes off, and the queue where things are added at the end of the queue but come off at the beginning. So that was an example using breadth first search and depth first search. Now let's compare using a normal list and a deque. Now we've said it's much better to use this double-ended queue, this deque, rather than a list. So let's show why. So here we're going to create a deque of 100,000 numbers and a list of 100,000 numbers. Now if we print that, we can see we've got the length of 100,001. That's our length. Now what we're going to do, we're going to create both the deque and the list. We're going to take out the element at the beginning and we're going to time it. So while that data structure has any elements inside it, that's the while loop, we're going to remove the first element. So we're going to keep removing the first element until it's empty. So when we print a list at the end, then the length of the list and the length of the deque, then it's going to be empty. But how long is it going to take? So we're going to set the time, and then we're going to measure the time it takes to do that while loop. So when we run this, we're going to expect that the deque, the first element is going to take less time than the second attempt with the while loop using just a list. Let's go through that again. We've got a deque of 100,000 numbers, we've got a list of 100,000 numbers. We're timing, taking the first element out until it's empty. We're going to do that with the deque, we're going to do that with the list, and then we're going to print to see how long it took. So let's run that. Okay, you can see, let's run that again just to check. You can see there's a considerable amount of time difference. Using a list is over 100 times slower. So over a period of time, if you're using an algorithm that uses a lot of iterations, if you like, then that difference is going to be huge. It's going to make the difference of your program running or crashing probably. So if you want to implement a queue, you definitely need to use the deque from collections. For our interest, we've tried to attempt the same code, but instead of implementing a queue, implementing a stack. So it's virtually the same code, but what we're doing is, instead of removing the first element of a queue, we're just popping from the end. So this doesn't make much difference between a normal list and a deque, but let's have a look to see if there is a difference in the time. When we run the program, we've got the size, we've actually used a bigger size list of numbers, and the time is about the same. So we've got, what have we got first? We've got the list first, and then we've got the deque second. So the list took slightly more time than the deque. We run it again and it's the same. So even with a stack that just pops from the end or the top, then the deque is actually faster than the list, although in this example it's quite a small difference. We've got one practice exercise, but we've split it into 5 parts. So let's go through them. Exercise 1, or part 1, create a list of 5 random numbers between 1 and 100 and then print that list. Exercise 2, put the first 3 elements from that list into a queue using deque and then print that deque or print that queue. Exercise 3, take out the first element from that queue, print it and print the rest of the queue. Exercise 4, add a 4th random number from the list and then repeat exercise 3. So add a number to the end of the queue, take out the first element, print that first element and what remains in the queue. Exercise 5 is the same, you take the final random number, put that at the end of the queue and print out the first element, taking it out of the queue, print that element and print the remaining queue. So that's exercise 1 to 5. We start off with exercise 1 where we create a list, we create 5 random numbers and we put them into that list. That's exercise 1. Now exercise 2, we create the deque, the double-ended queue, and then we append 3 of the random numbers, the first 3. We can print that and you can see we've got the list, random numbers 12, 71, 62, 97, 54, and the first 3 are in the deque. So exercise 3, all we need to do is take the first element out and then print that element and the rest of the queue. So when we run that, you can see here we've taken out the number 33 from the beginning and the rest of the queue's there. So we can do that again for exercise 4. We append the next element in the random numbers, and then we can pop left, print the element. So you can see here again the element 25's come out and we've added on 9, and we do again the same for exercise 5, where we take the last random element, print the first number that's come out from the beginning, and we put in the final random number. So that's exercise 1 to 5. If you've enjoyed that video and you've learnt something, then why not subscribe to watch more simple videos on Python to help you learn.